going through 2022 booklet B. 29A state what deforestation is. Now, this is actually a definition question. So because it's a definition question, you must memorize. There is no other way. Where do you find that information to memorize? Is in a set of consolidated notes that I told you. So at the set of consolidated notes at the back, I have a whole list of definitions that you must memorize. So what am I looking for? Is the clearing. Okay, it is not just the removal, but the clearing of large areas by cutting or burning down trees. For other purposes such as farming. So obviously, it may not be farming, but the main thing is that you are not, this is caused by, it's caused by man. It's not due to nature like a hurricane or anything. So it needs to be there. So what I'm looking for would be, you must tell me what is your method. And you must tell me what is your purpose. Okay? Next, state the effect of deforestation on the gases. Excuse me, ladies and gentlemen, it says multiple gases, 2 types. And when you think about it, right, in your syllabus, right, you are always focused on the 2 types. The 2 types of gases are namely your O2 or your CO2. O2 is oxygen, CO2 is carbon dioxide. In your examination, you are not allowed to use chemical formula. I'm writing this to save space. You must spell out the gases in full. Okay? So explain your answer. So when you think about it, your deforestation, right, okay, will result in less trees. So less trees then will result in less photosynthesis. So when there's less photosynthesis, there's 2 things that happen. Less CO2 taken in, and also less O2 given out. So in your explanation, I need to see things like photosynthesis. I need to see carbon dioxide in the surrounding increasing because there is less CO2 taken in by the plant. So there should be an increase in CO2 in your surrounding. At the same time, your oxygen levels should drop because now there is less photosynthesis. So translate whatever I have said, it would be deforestation results in decrease in oxygen and increase in carbon dioxide. I expect you to do the full correction as long as you don't get the full marks. Because if I can write, you can write. Now, then after that, remember cause and effect. So then the next part, you go that there is less trees, correct? So there are less trees to carry out less oxygen. To carry out less photosynthesis. Hence, less oxygen is being released, and less carbon dioxide is being taken in. By the trees. Okay, bonus point, if you can say resulting in global warming. You don't have to, but I want you to practice talking about global warming. Of course, if the question extends into how does having less tree or how does deforestation contributes to global warming, you do not need to talk about oxygen, but you have to talk about carbon dioxide. So this part here, can you see? In this question, they need you to talk about this. Oxygen is being released. Okay, and they need you to talk about how oxygen is being decreased in the surrounding, because they ask to talk about the gases. However, there could be a chance that in the PSLE they might ask, how does deforestation lead to an increase in global temperatures or global warming? Then you have to say that, oh, less trees to carry out photosynthesis take in less carbon dioxide. Hence, there is more carbon dioxide, which is a greenhouse gas, to trap more heat, resulting in an increase in global warming. So I am teaching forward with this, question. And yes, many of you, now you look at your work, you'll be very shocked at what you wrote. Right? I'm making sense, but I did teach you this one. Next. Now, what digestion is? Once again, this is a definition question. Ladies and gentlemen, do you realize that within one PSLE booklet, there are two definitions? So that is why I gave you a whole list of definitions to memorize. And this is also why I told you to check and check and check for your booklet A, because MCQ is worth 2 marks. This one, get anything wrong, 0 marks. Now for this question, many of you actually stated digestion is the process that breaks down large substances into smaller pieces, or breaks down large food pieces into smaller pieces. No. The key idea here is simpler substance. Simpler and smaller are two very different concepts. I was very clear about this when I talked about it. What does it mean? Simpler means it's a new type of substance. Smaller means you take a piece of paper, you rip it apart. Each smaller piece of paper is still a piece of paper. When I say a simpler substance, means that it's a totally new product. It is no longer what it used to be. That is the difference. Because it's a chemical reaction when it comes to digestion. Right? Though they say there's physical and chemical, but basically when they ask for definition, it's actually chemical. So what I'm looking for, digestion is the breakdown, not break up, be careful, breakdown of food into simpler substances. Now, there is another question, another definition that is very similar to this, and that is your decomposition. So decomposition is the breakdown of dead matter into simpler substances. So be very careful, make sure you get that right. So identify, substances J and K. So J will be your large intestines, and K will be your mouth. How do I know? So you look at your J, it doesn't digest food. There's only two organ parts in your digestive system that you learn. that doesn't have no digestion in it. One is your gullet and the other is your large intestine. Okay? So it's either gullet or large intestine based on this. Then after that, it says it doesn't chew, but it absorbs water. So you know that your gullet does not absorb water, so it's not your gullet. So absorption of water is actually who? Large intestine. And do take note, your large intestine does not just absorb water, it also absorbs excess mineral salts. Okay? Alright, excess mineral salts. It actually absorbs water and excess water and mineral salts. Okay? Maybe we remove the word excess, just mineral salts. This is very important. Okay? So how do I know K is your mouth? It chews food now, the chewing of food. Please don't, it cannot be anything, it cannot be a large intestine chew food, right? Your small intestine also got no teeth. Next, this part here. Name two substances. Some of you only name one. How can that be the case? So which are higher amount at Q. So indicate, so Q is higher, P is lower. So Q is lower, it goes after your small intestine. So your small intestine, remember, is in charge of absorption of digested food into your bloodstream. So because of that, you know that any blood that leaves your small intestine now will be rich in digested food. So your first answer here must be digested food. Then after that, because your small intestine is made up of cells, right? It's a living thing, or rather, each cell is a living unit of life. And I told you this before, everything that is living will carry out respiration. So when you actually have respiration, you will actually produce what? Carbon dioxide. So the next one is actually carbon dioxide. Okay, because as it passes through, your blood passes through here, it will actually transport oxygen to the cells in your small intestine. At the same time, it will collect your CO2. Correct or not? Okay? So these are the things that you need to actually realize. Name one substance that is higher at P than at Q. So you ask yourself, what is being used up? Oxygen. Right? And what is your oxygen used for? Your oxygen is used for respiration, which I have told you many times. You see how this is coming back. Okay? One full circle. Okay? Okay. Nicole wanted to study whether liquid tea is more effective in killing bacteria compared to soap. Nicole rubbed her right thumb on the tabletop and cleaned her thumb using soap. So, straight away, I will annotate here. This is actually the aim, whether tea is more effective compared to soap. So usually within my aim, I'm able to find my change variable and my measured variable. So over here is not super clear, but I know that there are two things, liquid tea and soap. So this is my change variable, isn't it? And then after that, I want to know, okay, whether is it effective at killing bacteria. So something that I must have measured must be a proxy that can tell me whether or not is it more effective. And in this case, if you read further, you realize is the number of bacteria that is still alive. That is actually your measured variable. Okay? So Nicole rubbed her right thumb and cleaned her thumb using soap. She recorded the number of bacteria at 3 minutes and 1 hour. So as what I said, this is actually your measured variable. After cleaning with soap, the process was repeat. Okay, then you got this. So you need to learn how to actually read. Usually on the x-axis. Don't know what is your x-axis, is your horizontal axis. Okay, usually this is your change variable and your y-axis is your measured variable. Okay, so this one, the one in blue, is using soap. Okay, I'm going to highlight for you so you can see in blue. And then the other one in pink is actually using liquid tea. Alright? So if you take a look at this, the question state what Nicole can conclude. The keyword here is conclude. So if you remember, I said when it comes to conclusion, you always must look back at what is the aim. But most of you didn't. You just went, liquid tea is more effective. Effective at what? At what? Right? Yes, so you have to go back to your aim. And the aim clearly states here, she wants to find out who is more effective in killing bacteria. So in your conclusion, you must talk about who is more effective at killing bacteria, not just go more effective. Huh? More effective at what? There are so many other possibilities. It's something that's very simple, right? I taught you this before. Right? So then, the first part is the easy part. Okay, the conclusion will be liquid tea is more effective at killing bacteria than soap. How do I know that? Very simple. I look at 3 minutes. Okay, you all don't copy first. You all look at this. When I look at 3 minutes, okay, so I'm assuming they all start off with a certain amount. I don't know how much. I'm going to assume that it is the same amount. Okay, I don't know. But basically, they all started off with the same amount. So, if you see, after I applied soap as well as liquid tea, after 3 minutes, this amount of bacteria got killed when I use, what is this? Soap. But whereas this amount got killed when I use liquid tea. So you see, I'm looking at 3 minutes for killing of bacteria. For killing of, yes, because it's immediate now, assuming they all started off the same. This one decreased by so much. This is for soap. This one decreased by so much. This is actually for liquid tea. So based on that, I can conclude it's more effective at killing because this one killed more than this. It's very obvious, isn't it? Now, this is the part that many of you are doomed. Explain your answer in A1. Hear me out first before you start copying. There are 2 times here. So 3 minutes and 1 hour. If you do not state the timing, straight away is 0 marks. How many marks? 0 marks. Because these two represents 2 different phenomena. If you do not state what are you explaining, 0 marks. So in the first one, you're focusing on which one is more effective at killing the bacteria. Can you see? The second one, what you don't see is now from this part here. What is this part that is I'm highlighting in red now? This part is reproduction. Yes. So they have multiplied. And then after that, this one over here, this is the amount that if you use liquid tea and multiply. So if you solely compare this amount to this amount, which one has a higher rate of reproduction? Of course, it is your soap. So in your answer, you need to state two different trends. The first one tells me that liquid tea is more effective at killing bacteria. Why? Because there is less amount of bacteria left as compared to soap. Right? Then we have to talk about 1 hour. At the 1 hour mark, you realize that the increase for soap is a lot more compared to the increase for liquid tea. This tells me that liquid tea is more effective at slowing down the reproduction rate because the amount of increase is much lesser than when you use soap. So there are two different phenomena. One is about killing, the other one is about stopping or slowing down reproduction rates. You see what I mean now? Without quoting these two, you are gone. And this, if you ask me, is one of the more trickier questions. How many marks? 2 marks. That's why I say you need to try and score 52 and above for your booklet A. Because this is where you should, inverted commas, be losing your marks. Because it's difficult. Okay, so what will my answer be? So at 3 minutes, the amount of bacteria for tea or liquid tea is less than soap. Hence, liquid tea is more effective at killing bacteria. Right, this is the first trend. The second trend, at 1 hour, the rate of reproduction for liquid tea is slower than for soap or than soap. Hence, liquid tea is more efficient effective at slowing reproduction of bacteria. For this part, state how using the same thumb instead of other fingers help to make the study a fair test. Now, when you talk and you explain about fair test, there is actually a template that you can follow to explain. Firstly, the main reason is because you want to ensure, okay, and confirm that the only change variable is actually whatever that is mentioned in the question affecting the measured variable. So in your answer, two things must be mentioned: change variable and measured variable. I'm going to explain to you in a while when I craft the answer. Okay? And you also need to then say about how the specific factor or variable that was brought up, it being the same, actually affects the experiment if it's not the same. So you think about it, you flip the question and ask yourself, what if you don't use the same term? What is it that could have affected? So then you think about what you're measuring. In this question, you are actually measuring number of bacteria. So can you imagine if you started off with different number of bacteria, or you started off with a different exposed surface area of your tongue, which may then contain different number of bacteria. So in that sense, it's not fair already, ma. So if you, for example, let's just say you use your thumb. Your thumb has the largest exposed surface area. So based on the fact, I can also assume that it has the largest amount of bacteria on it. Then if you use another finger, say your pinky, it has the smallest exposed surface area, which means that it can also have the smallest number of bacteria on it at the start. So it's not fair. So you need to remain consistent. So when you craft answer like that, in your answer, you must mention the change variable, the measured variable, and the factor that is specific to that question. So I'm going to show you how it's done. So firstly, whatever I'm writing in dark blue now is what you will copy, cut, and paste exactly. So this is to ensure that this is where you write your measured variable. I'm going to use pink color for measured variable. But you cannot say measured variable. You have to think about what is the measured variable in this specific question. And the measured variable for this question is number of bacteria. That the number of bacteria, which is your measured variable, okay, is only, so this is a template, copy, cut, and paste, affected by, so this is the change variable that you must talk about. So in this experiment, what is the change variable? The change variable is the type of liquid, right? So it's only affected by liquid, type of cleaning liquid, or you can just straight away say liquid, tea, or soap. So this is your change variable. Do you see it? And then after that, the last part, you have to talk about what is the factor that is specific in this question that you're keeping the same. So it is actually the same term. So the same term will ensure that it has the same exposed surface area. So this is the reason why in your paper you will see there, I put a caret there, missing key concept SA, surface area. Okay? And then you continue to go and not the difference in exposed surface area of the fingers. So can you see this part over here? actually came from here using the same tongue. Right? Just that I flipped it. Okay, this is how you need to answer. So where is this template found? It is found in your notes. Next. Okay, I'll wait here for a little while. Any questions? Am I clear? So you have to memorize one. Fair test will confirm come out one. So if I were you, right, I will memorize this. So that's why I tell you, all your PSLE papers that I'm going through, it cannot go missing. Because if I'm going to study, right, I'm going to look at my PSLE paper that Mr. Chong has gone through with me. What are the ones that he says that will come up? I need to memorize. So I will memorize this answer, but I will replace this, and the last part. Next. Okay, this question. Now the diagram shows an outdoor toilet for collecting human waste. So straight away, human waste, you need to understand. Human waste has two factors. There is the solid waste, of course these are your feces, but you also have your urine, which is the liquid waste. And then when you go on to read further, state why mosquitoes like to lay their eggs. So do you remember I told you this before? Mosquitoes is one of those life cycle that they like to pass on because it is very prevalent in Singapore. Real life application. And ask yourself this question. Lay their eggs, likes to lay their eggs. What is it that the mosquito needs in order to lay their eggs in? Yes, so you all know, you told me you need stagnant water. So this is where you need to be able to relate the water part to the liquid part of the waste. So you need to say that waste contains water or liquid for the mosquitoes to lay their eggs in. Right? So that's why they like to lay in waste. It's because of the liquid component. So that must come out strongly. Now, gases are given up by waste. A lot of you actually put here, group of living things is mammals, process is respiration. That is wrong. Why? Because the waste who have hinted me that it's probably got to do with something like decomposition. Because the definition of decomposition is the breakdown of dead or waste matter into simpler substances. This is where I would see this, right? And you know that the gases, right, in this case is actually carbon dioxide. When you break dead matter down, you release carbon dioxide. So the group of living things in this case here is bacteria. And then after that, the process here is decomposition. Not respiration. No, because you don't digest waste. Right? You cannot be digesting waste. Next. Now, diagram 2 shows an equipment X which traps and kills the mosquito. So you have this plastic dome, okay, and then you have this tube that carries gases from waste. Gases given out by the waste are carried in a tube and released at the opening. Suggest why the gases released attracted mosquito. So in the first place, you need to understand the first important point. This gas came from the waste. So when you think about it, it's just like I asked you a question. Why are you attracted to the kitchen when your mom is cooking food? The smell, right? So you know that the smell came from food and you are attracted to the smell because it suggests that there's something delicious to eat. So that's why you're going to the kitchen. So the same thing over here, is that the mosquitoes are attracted to the gases because it came from the waste. And the waste is beneficial to the mosquito because it contains liquid for it to lay eggs. So the smell which came from waste suggested to the mosquito the presence of waste, which contains water for it to lay its egg. Okay, so the smell suggested, okay, there will be waste, and so the mosquito will be attracted to it. Okay, this question is a bit trickier, so I need your fullest attention. Now, over here it says, the opening allows air and mosquito to enter. So air can go in. So there were quite a number of you who said, oh, the mosquito died because there was no oxygen. Cannot be, because air can go in. Suggest why mosquito in the clear dome died quickly. So the key word here is die quickly. A lot of you ignore the key term quickly. Let me ask you a question. If you have no food, will you die quickly?
No.
No, you will take a week or two, right? Even if there's no water, will it be very fast? No, even without water, it will take about 3-4 days before you finally feel the effects and you will pass away. It's quite difficult, you know. But the key word here is die quickly. So the reason why over here, many of you did not recognize, was that this is a clear plastic dome. And this actually looks like a greenhouse. Right, so as you know, greenhouses are made of glass, okay, and what do greenhouse does? What do they trap? They trap heat, correct. So they trap heat. So similarly, your plastic dome traps heat and is the extreme heat that killed the mosquito quickly. It's hot. You know, have you been into your father's or someone's car when it's parked under the hot sun? It's very hot, right? It's like it's like a greenhouse. It's really hot. So you imagine the poor mosquito now. Can go in, cannot come out. Hot. And so that's why it died quickly. Okay? So therefore you would say that the heat trapped in the dome resulted in the high temperature in the dome. The heat killed the mosquito. Okay, continuing on question 33. John left a piece of stem standing in the red color water for an hour as shown. Name the part of the stem that was stained red. So the red stem is this part lah, okay, over here. So obviously we know that since it's red color water, it is dealing with your water carrying tubes or xylem. Okay, so this is half a mark. Then the next part is to state its function. So because the function over here is a transport function, so I mentioned before already, anything that's got to do with transport, it is paramount that you mention from where to where. And then also what is it transporting? So many of you have left out mineral salts. I told you this before. You cannot leave out mineral salts. If you do, 0 marks for the second half of it. So half mark for telling me that it's water carrying tubes, half mark for telling me that it transports water and mineral salts. If you're really good, water and dissolved mineral salts from the roots to all other parts of the plant. Okay? So what am I looking for? Transports water and dissolved mineral salts from the roots to all parts of the plant. You can also say leaves. Okay, that means this part is replaceable with leaves. I will give you that as well because water goes in one direction, which is to the leaves. Okay, however, because there's also the mineral salts, there are certain parts of your plant that may need the mineral salts. So both are acceptable in this case. But the key idea is we want to know whether you know where does it go to. And yes, I know the roots are missing here, but that does not change the primary function of your water carrying tubes, and that is to transport from roots to your leaves. Now, this is the part, okay, you need to be careful. John wanted to find if temperature affects. So this is the change variable. Some of you have mentioned that, you know, this, but wait, you were very general, okay? Change the temperature. Temperature of what? Temperature of the plant, of the stem, of the beaker, of the surrounding, of the water. You just told me, change the temperature. And then you will see in my remark, GS, general statement, and then I'll put temperature of question mark. This is where you will lose marks because you are asking the examiner to guess temperature of what thing. So basically what we are looking for is temperature of the water. Right? That is the most accurate and okay, and why is it not so readily acceptable for temperature of the environment? It can be quite difficult to control. Okay, and in this case, the one that is in direct contact with your water carrying tubes, right, is the water. So this is the best answer. I'm marking for best answer now. My aim once again is to make sure your answer does not give the examiner to minus any marks. That is the purpose. So I am restricted. Suggest what John should measure. So what is your measured variable? And then many of you say, oh, measure the amount of water left. Now, you need to look carefully. Look, let's read this together. Wanted to find out if temperature affects the rate of movement of water in stems. So you want to find this out. So remember, what is your measured variable? It needs to be something that is related to this. It needs to act as a proxy. Because you cannot directly measure the rate of movement. Just the one I told you. You cannot measure rate of evaporation. You can only measure the amount of water left at the end of the experiment. You cannot measure the rate of photosynthesis of a submerged plant. You can only measure the number of bubbles produced per minute. Very good. So what happened to here? No. A lot of you didn't bother to tell me anything about the rate part. You all just went, measure remaining water. Measure this, measure that. You never say per minute. You never say per unit of fixed time. Right? They're asking for rate. So somewhere within your answer, you need to tell me, measure what at fixed timings or fixed periods of timing. So like every minute, every 10 seconds. Then it's rate what? And the next thing, a lot of you gave me the answer, measure the volume of water left. So I did not accept this answer because if you take a look at it, this is not a measuring cylinder. How are you going to measure? Every minute you pour out the water. How? How are you going to do that? That's impossible. This is not a measuring cylinder. This is not even a beaker with indication of any measurements at all. How? So actually what they wanted you to do was this. You would divide maybe I use a different color. Divide this stem into equal intervals. Then after that, you will measure the time taken for your water to travel to each interval at fixed period. How long it took to travel at each interval. Okay? So basically, you should be able to, I'm assuming that it's quite thin, like celery or something. You can see the water traveling. Okay, because it's red color dye. So even though you did not cut, right, you should be able to see it going up. So that is how you're supposed to measure the most correct answer. Okay? Now, there is another one that you can say that I will accept. Time taken for your xylem vessels to appear red or to be stained red. Right? So very simple, right? You have a few set up. So you see, this one took 10 minutes, the other one took 2 minutes. So basically you can see how, temperature generally affects the rate of water moving up. But because they say rate of water, they wanted something more like per minute or per interval. So that's why actually the first answer was actually better. This is one of the more difficult questions. I would actually have to agree with that. Okay, so he should measure the time taken for the red water to travel up fixed intervals of the stem. Am I clear? Who's unclear with whatever I just said? Oh, okay. So the key idea here is the red part that you all are missing. The red. Okay, and another thing why you cannot one more reason why you cannot measure the amount of water that is left okay, very importantly anyone realize something? What is missing from this experiment that does not allow you to do that? Yes, very good. The layer of oil, right? The layer of oil is missing, so it could be due to evaporation. Okay? Because at higher temperature of your water, it means your rate of evaporation will also be higher. So cannot. Okay? So convince all those who wrote measure amount of water left. Next. Okay. I realize that your papers are very clean. You need to annotate. John conducted experiment to investigate the effect of temperature. So this must be my change variable. And the rate of photosynthesis. So this is like my measured variable. But once again, I cannot be measuring photosynthesis directly, just so you know. So anyway, they then presented the results here. So many tiny openings. So these are many tiny openings straight away, right? I will know that this is my stomata. And when I know that it's my stomata, there are two functions of stomata that comes to my mind. One is water loss, right? And this is known as also transpiration, which is the loss of water vapor through the openings. The second one is actually gaseous exchange. Now this gaseous exchange, you need to understand. I cannot tell you what is exchange with what, because there are two scenarios. Anyway, the two types of gases that we are interested in is which and which? Oxygen and carbon dioxide, CO2. Once again, I stress, you are not allowed to use chemical formulas in the PSLE. You need to spell it out. Now, why I cannot tell you what is exchanged by what, right? Okay, but I know it is the exchange of these two gases. It depends on the situation. If it's in the daytime, under bright light intensity, you will actually take in carbon dioxide and give out oxygen because you are photosynthesizing at a very fast rate. So fast until that you will consume the CO2 that is made by respiration of the plants. But at night, when there is no photosynthesis, you will actually take in O2 and give out carbon dioxide. Because your carbon dioxide is not being used for photosynthesis, it is in excess at night. So it will be given out. Am I clear on this point? Am I clear on this point? Next. It is extremely important that you realize that your stomata are formed by two cells. These are called your gut cells, whereas these are not your stomata. This is your stomata. So your stomata is nothing but an empty hole. So you cannot say that, okay, the stomata takes in carbon dioxide. Cannot. Because it is suggesting that the hole here, okay, is able to carry out an active process. Meaning that the hole is able to take in. No. Gases just pass through the hole, that's it. So you need to be very careful in your answer. It is not the stomata that takes in the carbon dioxide, or rather it is the plant that takes in the carbon dioxide. So your stomata opens bigger to allow the plant to take in more carbon dioxide. You need to be very careful about that. Okay, or rather the stomata open bigger so that more carbon dioxide can enter the plant. So you need to be very careful about that, because you will be penalized. You will be penalized if you say stomata takes in carbon dioxide. Now over here, So we take a look at the trend. I don't see any of you doing it, you know. This is increase and this is actually increase. You have to do this. This will help you to be very clear about what you are looking at, what is the trend. In exam, right, you could be very panicky or you could misread something. So pen it down because thoughts are slippery. Thoughts are slippery. Write it down so that it's easy for you. Now, using the result shown, if you have a graph or a table, you must talk about the results. You cannot jump straight into your explanation. So that's why if you take a look at it, it's always results first and then explain. So explain is cause and effect. Okay? So, right over here, we look at the question. Using results shown in the graph above, explain how the change in size of stomata openings at a higher temperature help the plant. So we go back to here. Which function are we looking at? We are looking at function number 2, gaseous exchange. Okay? So in this case, if you look at it, right, when your temperature is higher, what you want to see is a bigger opening so that more carbon dioxide can enter the plant. Okay? And that will lead to an increase in photosynthesis. Yeah, so you must mention that. So first, we need to talk about the results. So the first part will be as temperature increases. The opening opens bigger or become bigger. Then what is the effect? This is the cause, right? What is the effect? This allows more carbon dioxide to enter the plant, or allows the plant to take in more carbon dioxide. Okay? Therefore, cause and effect. So now the effect has become a cause. Therefore, increasing the rate of photosynthesis. So usually, right, this itself will give you 1 mark already. Because you're talking about the trend, you're talking about the results. They never show you the trend what? They say change. Okay, they say change in size. Do you see or not? It was never mentioned did it become bigger or smaller. So by me saying that it opens bigger as temperature increases, already is usually 1 mark already. Because the whole thing is one trend. Then after that, allows more carbon dioxide, half mark, increasing rate of photosynthesis, half mark. Because when you increase rate of photosynthesis, you're making more food. And more food is related to more growth for the plants. Hence, that is how it helps the plant. Any questions? No? Moving on. State 2 factors in the surrounding. Okay, this type of question, okay, you need to be very careful. They say in the surrounding. Some people talk about the plant. You tell me, oh, the plant needs to be the same. How is that possible? You are not answering the question, and quite a number of you, instead of talking about the surrounding, you talk about the plant. That's not right. So everything else needs to be the same except for the change variable. So the change variable, if you look here, is actually temperature, right? So you would say that, okay, there are many, wind speed, the volume of water given to plant. What other environmental matters that matter? The light intensity. Okay, I also want to stress that the amount of light is correct, but it's not the most correct way of describing light. You should use intensity, which I have talked about it many times. Just like how you will use volume to talk about water and not amount of water. Okay? Though in exams, I'm almost pretty sure that they will give it to you correct. But we want to make sure that we use the most accurate quantifying term. Any questions? Next. Okay, guys, spring questions are becoming very popular, and this is one of those questions that students always have issues dealing with. But if you follow what I say, don't worry, you won't have a problem. Okay, so I need to pay very careful attention to what I'm going to tell you. Now, Ming Xin conducted an experiment on a string made of material R using the setup below. Okay, so he added a mass of 100 grams and measured the length. He repeat this until the mass reached 1,000. He then repeat with another spring of the same thickness, okay, but made of material S. So the change variable here is the material. Everything else needs to be the same. So straight away, even without looking at the question, I see red flags already. How come they did not both start at 60? Right? They did not both start at 60. This is actually S. S started at 61. So red flag already. This is not a fair test to me. Without even looking at the question, if I understood this. So you need to be very careful. Some of you said both strings did not start at 0. Huh? You misread the x-axis, the mass, as the length of the string, and you tell me both of them need to start at 0. Excuse me, if it starts at 0, is there any string left? Yeah, means 0 string. So you need to sometimes check answer, also think about whether is it logical or not to have 0 string. State the mass added when the string is at 63. Use a ruler, please, people, use a ruler. So 63 as here, S is here. Make sure you highlight the correct thing. Draw a straight line using a ruler and then go down. So my answer here is 400. Make sure you put the units, the SI units, gram. If your gram is missing, deduction of half a mark. Next, state the increase in length. A lot of you did not bother to read. They said increase. They did not say the length. So a lot of you told me the length instead of the spring. So a lot of you just went, 0 to 800. And then all of you happily looked at string R. Okay. And then you look at 800. And then you tell me the answer is 62. Wrong, because they're asking for increase. So you need to take final length minus initial length. That is the formula. So final length is actually 62 minus away 60. And this is actually in cm. Okay, so answer 2 cm. You don't have to show the working, but I'm showing you the most mathematically correct way of doing it. Explain why the experiment is not fair. So you should have just said string L and R did not, or were not of the same length at the start of the experiment. Let me explain to you what is the common fallacy. The common issue was that a lot of you omitted this part, start of the experiment. Straight away you say, string L and M were not of the same length. Excuse me, do you realize that they were not of the same length throughout the experiment? Do you realize that? They are not. So though even as an examiner, I know what you are trying to say. But because you lacked the start of the experiment, you basically did not get the marks. Yes. What did you say? Oh, sorry. String S. Thank you for correcting me. Okay, so basically, you all understand what I'm saying, right? And then how to use bracket. So some people ask me, Mr. Chong, can you actually use bracket or can you actually use point form? It's not that you cannot, you can, but you must know how to use it properly. So if it's me, right, I will put a string S bracket, so string S started at 61 and R started at 60 cm. Right? So it's very clear why they are of difference. So in exams, I know, wow, this child is very good. String S 61 cm, R 60 cm were not of the same at start experiment. Very clear. We provided evidence. But do I actually need you to even state this? No need. Because you really tell me why they are not of the same length. It doesn't matter what were their lengths. Doesn't. Because the fact is, they didn't start at the same length. Because of that, it's no longer a fair test. Suggest why no results. Okay, this is also another one that you need to explain to me. Why? Because it snapped. Don't say it snapped, but never tell me why. Because it snapped when 800 or more weights were placed on it. That's why, because they were wondering, how come no more already this part? Where? From here to here, where? Where is the results? No more. Why? Because it snapped when 800 or more grams or heavier weights were put on it, right? So, the string broke when 800 gram or more or greater mass was added to it. So it is this part that you're missing. It's broke, but you never tell me why. Okay, because this is suggest why. Too heavy. String cannot take it, break. We want to pause for a while. Any questions? Am I clear? Yes. Okay, you may have your snack break very quietly. Okay, while I go through. Next, this is a question that I'm going to spend some time on. Now, electrical system. Nowadays, they will pair electrical system with forces, okay, or even magnetism. So in this question, the electrical system is paired together with both magnetism as well as forces. Okay, so I'm going to break up for you. Kumar set up the apparatus as shown. A, B are identical iron rods. So basically when you see iron rods, what flags to me is that this could be electromagnetic. And I'll put a question mark here. Because why? Mr. Chong said that usually that could be the case. And the fact is that it's iron rod hints to me that they can be. Okay? So I'm going to pause here and I'm going to forward teach a little bit and do a little bit of revision. When you see this kind of circuit, you need to use this format to answer. CEO. Okay, not Chief Executive Officer, but C stands for is your circuit closed or open? E stands for can your electric current or your electricity flow through? Flow through where? Circuit. Lastly, your outcome has 3 common outcomes. I'm not saying that it's exhaustive. I don't know what PSLE will come out this year. But usually, number 1, light bulb. This is outcome. So then, light bulb will light up. Number 2, electromagnet. Right? They will say, oh, electric currents can flow through the circuit. Hence, iron rod becomes an electromagnet and attracts something. You need to write about that. Third one is actually your buzzer, okay, or something to make sound. So in this case, it's your hammer. So wow, this is a quite high ability question that straight away they test you an electromagnet and they also test you a buzzer. But it's not like they've not tested you before. The PSLE, right, they always come out with this view. If you take a look at all the past year's school papers, everything, it's like that. It is what it is. Okay, so now that I've taught you this, I've revised with you this, okay, we're going to use this to answer. And you will see how this helps you to craft an answer. Can I just check? Does this ring a bell to you? Yes, right? I taught you this before. Okay? So you need to use this to answer. So let's go. So let's continue with the question. So that means this 2 is iron rod. So how do I confirm? I look here lor. Wow, still got coil around it. Okay, confirm already. This 2 must be electromagnet. Somewhere within my answer, my outcome, I must talk about this. And the electromagnet must attract something. Do not attract what? Okay. And is fixed in place. Okay, so this one cannot move. PQ is an iron bar. Wow, another one. Can it be another electromagnet? I check. PQ is here. No leh. This one don't have the wire coil around it. So okay, this one not electromagnet, but it's magnetic material. So what does it mean? Okay, maybe it'll be attracted to the electromagnet. I'm not so sure. Okay? And you know what's the thing that I think that this is the one to be attracted? Okay? It's because of the metal nail. If they wanted the metal nail to be attracted, they will say here iron nail. Because there are certain metals that are not magnetic. For example, okay, aluminum is not, copper is not. Okay, and rest on a metal nail. So basically, roughly what I know is this one will get attracted to this. So when this one goes up, the hammer will be brought closer to here. Then they are in contact. So they will sound the fixed bell. They will hit it. So, okay, I didn't know how the whole mechanism worked already, more or less. And then when this one hit the top part, I realized that there is a gap now between my fixed metal nail and my PQ. So there is a gap. And then this one will no longer be an electromagnet and it falls back down to its original place. Okay? Now, let's go. So when he closed the switch, the hammer struck the bell repeatedly to give a continuous ding 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 sound. Explain how the sound was produced. Because it's ding 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 ding, there is a gap here. This gap here, you need to talk about the open circuit, which some of you forgot. So that's why you only score 1 mark. Okay, so how do I translate whatever I described into words? Okay. So let's do this together. He said close the switch, right? So when he closed the switch, the circuit is closed. And electric current can flow through the circuit. Be very careful, it's flow through the circuit and not flow through iron bar AB and DC. No, just in case you all don't know, electric current doesn't flow through the bar. It flows, okay, the wire coil. I want to be very clear on that point. Okay? The minute you say that is a misconception, deduction of marks. Next, iron bar A, B, and C, D becomes electromagnet and attracts iron bar PQ. Okay? Hammer will move up and hit the bell. Up to now, this whole entire thing is talking about the ding. You realize that? You have to say, when the attract iron bar PQ, the hammer will move up, and then it will hit the bell. That is how you get your ding. So let's go back to this part here. CEO. Where are my CEO? I'm going to show you right now. Circuit is closed. This part is my C. Electric current can flow through the circuit. This part is my E. And then after that, this whole part here is my outcome. Do you see that? Do you see that? Am I clear? Very clear, right? I just follow. And then my dot part, how? Where did my dot part? That is the part that it stops ringing. Yes. So then after that, the iron bar PQ is no longer touching or in contact metal nail. Then after that, CEO again, the circuit is open. Iron bar iron bar A, B and C, D, yes, lose their magnetism or are no longer electromagnets and Q drops back down or returns to its original position. I must see that somewhere. And then finally, the process repeats. Okay, so this whole part here that I am talking about is got to do with your dot dot dot. This whole part is the dot 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 part. I know it's very long, but can you see this is required? There is no way I can explain the dot 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 and the date without talking about it. Right now, you take a look. There's no way. It is what it is. Because it's such a commonly tested question. In exam, this is what you're required to write. So that you don't get deduction of marks. And this is extremely clear. Step by step, cause and effect. Anyone here disagrees? No, right? So follow. And this is also why I say your MCQ booklet A, you cannot afford to even lose one question because it is very tedious. Okay, now the next one. Kumar replaced the spring with a stronger spring of the same size. When he closed the switch, the hammer struck the bell repeatedly. State one effect on the sound produced. Explain your answer. Now, you need to state and you need to explain. So it's a cause and effect question. Granted that you see the word spring here, I will see spring in two chapters. One is on forces, another in energy. When you talk about energy, is your elastic spring, okay, your elastic potential energy. And then when you talk about forces, is your elastic spring force. So in this case, you have to decide, are they talking about force or are they talking about energy? Force, because there is no energy conversion here. They didn't say anything about it, right? So I'm going to talk about it in terms of force. So in my answer, I must talk about, okay, my elastic spring force. And then they also say that it's a stronger spring. So when they say stronger spring, okay, in spring, what do we usually use to describe? Stiff and stiff, more stiff and less stiff. So a stronger spring would mean that it is more stiff. So in my answer, I should also mention about that. So how will my answer look like? Let's take a look. So now you have something that is stronger or more stiff. Now you realize that it needs to, when it sounds the bell, it needs to go upwards. So what happens when this becomes more difficult to compress? You hit it with less force. And then after that, you produce a softer sound. Right now, because now this is more difficult to compress because it's more stiff. So when the hammer go up, it will not hit it so hard. So you need to first answer the first question. The sound will be softer. Now then the next part, cause and effect. As a stronger spring is more stiff. More force is needed. Wait, sorry. Can we go back? Hold on. More stiff. Okay. My mistake. Go back. It is more difficult / more force needed to compress it. Okay, you have to mention that. Hence, the hammer will hit the bell with less force, producing a softer sound. Okay? So because you kept everything the same except the spring. So now the spring is more difficult or more force is needed to compress the spring. But you didn't increase the magnetic force. Okay, it remained the same. So because of that, it got compressed less. So somewhere in your answer, right, you must say that a stronger spring is more stiff, so it's compressed less, or you have to tell me it's more difficult to compress. So it gives me the idea that now the spring, because it's not as compressed, it will not hit the hammer will not hit the bell with so much force, producing a softer sound. Am I clear? Okay. Next. State the effect on the sound produced if a fixed metal nail is replaced with a wood. Okay, this one you were very careless. In the first place, is this question about magnetic or non-magnetic material? Yeah, it's not. It's not about magnetic, non-magnetic. Some of you went, oh no, because wood is a non-magnetic material. Huh? No. No. In the first place, this entire thing, your metal nail was never supposedly to be a magnetic material. Its role is just so that electric current can pass through it and flow. That's all. Its role is actually to be a conductor of electricity. So when you replace this with a wooden nail or wooden item, wood is an insulator of electricity. So because of that, there is an opening, a gap. Okay, so what your answer should be, okay, no sound will be produced, not softer, no sound will be produced. And then after that, explain your answer. Wood is an insulator. You cannot say wood is not a conductor. If it's not a conductor, then what is it? Then what is it? Right? So it's an insulator of electricity. Hence, an open circuit is formed. Cause and effect. This is the cause, this is the effect. Clear? Okay? And this is what I'm marking for. Half mark for telling me no sound, the other half mark goes to the part that you're able to tell me that wood is an insulator. One look at this question, more or less I would know that this question has got to do with forces. Why? Because it showed something like a rubber band. Okay? But we shouldn't jump to conclusion. This just gives me something to prep my mind. Okay? And then I read on. Peter has a flying bird toy. When he turns the handle, the rubber band becomes twisted. So this twisting part, right, tells me that it is being stretched. Alright? And the plastic wings move up and down as shown. Peter turned the handle 50 times and threw the toy into the air. The toy flew from A to B and then from B to C before stopping at D as shown in diagram 2. Fill in the boxes the main forms of energy when the toy is flying from A to B. Believe me or not, whenever there is a question either on forces or on energy, you must ask yourself, is the question asking for energy or for forces? Because these two are related. Just like how I said in the beginning, I think it's maybe got to do with forces. But it can also be due to energy. So you need to be careful. So in this case, it's form of energy. And then after that, for energy, right, ask yourself, is it elastic potential energy or is it elastic spring force? There's no such thing as elastic spring energy. Don't laugh. You all know, right? You always do this. The other one is the gravitational potential energy and gravitational potential force. For some strange reason, you love to mix these two. So check and check. So rubber band, when it's stretched, obviously this is actually your elastic potential energy. Make sure you write the word energy. If not, there is the deduction. There may be a deduction of marks. So some of you may go, no leh, but sometimes I put heat is okay. Because heat itself is a form of energy. Okay? But there are other things that are not, so you need to be specific. So when it comes to your toy, so remember, energy cannot be created or destroyed, it can only be converted or transferred. So when it comes to a toy, you realize that it's going upwards. So no need to say already lah, from here to here go upwards. One of the key things here that many of you miss will be your gravitational potential energy, right? Instead of saying this, many of you will tell me heat or sound, along with kinetic energy. So kinetic energy is the one that all of you managed to get. No problem. Okay? However, it is this one that you missed out. And then you all go, Mr. Chong got sound why cannot put heat? There's heat what, there's friction. There's friction between the plane as well as the moving air. I will not disagree with you, but that is not the key energy conversion. The key on energy conversion is actually the increase in height. And how do you justify for that? It's gravitational potential energy, isn't it? In fact, that should be the first thing that comes to your mind, is increasing in height. Right? Anyone disagrees? No, right? And then you look at your answer. What happened? And once again, this proves me right. For students like you who are very smart, it is always the easy question that gets you. So check. Now, explain why the toy flew lower and lower from C to D. Now, I am going to highlight this one thing to you. It's going lower and lower. What is causing it to go lower and lower? Something must be pulling it down, right? Yes, so the key thing here is gravitational force. So while this may be usually, like I say already, this paper it is one of the more trickier paper. Usually it's very straightforward one. When it comes to energy, right, they will ask you something like, how do you make the plane fly higher? Then you say, twist the rubber band more. So there's more this, then become more this, then become more this, and so go higher. But in this case, it is actually a mixture between forces and energy. This particular question here. Where's the force? Gravity. Gravity is a force. So because it says lower. So the part that is lower is actually that the gravity is acting on it to pull it go down lower. And then where's the energy part? You talk about how when the rubber band untwists itself. Look here. So it became twisted. So as your plane goes, it untwists itself, it becomes less stretched. So less stretch means what? Less elastic potential energy to be converted to kinetic energy and gravitational potential energy, right? Think about that. So that's why the propellers or whatever, or the wings actually flex lower. So it won't go higher, lor. It will slow down and go lower, and there's gravity pulling it down. So why the gravity is important? If you don't mention gravity, technically the plane should move slower at the same height in the air. It won't go down. You see how this is broken up into two parts, the energy portion as well as the forces portion. So I'm going to use two colors to help you answer. So for the first part, I'm going to use red, okay, as the rubber band untwists. There is less elastic potential energy to be converted to GPE, gravitational potential energy and kinetic energy. Okay, at the same time, gravity is pulling the toy downwards. So can you see these are the 2 points? Am I clear? Are you all convinced with my explanation? Okay, there are 2 parts to it. One is about the energy, the other part is about the gravity acting on it forces. Yes? Okay, the next question says, Peter added another rubber band to the same type to the toy. After turning the handle 50, he threw. Draw a curved line to show the new path. So basically, when you add another rubber band, you are so-called, making it harder to twist lah. And the way you think about it, maybe it's stiffer. So, and you still twist it 50 times. So technically, it should have more elastic potential energy. So everything is more, correct? So what am I looking for? Firstly, I'm looking for the fact that it needs to start at the same point. Some of you, very adorable. You start here. Wow, now Peter can fly. No, you think about it, this is height, right? Hello, it needs to start at the same point. Then after that, some of you, very interesting. End at the same point. You don't laugh. These were some of the mistakes. No. Then got one more artist. Even better. Hello? This is not art class. No hairy lights. So technically, and a lot of mistake, one more other mistake you all make. Don't laugh. From here is okay. Then I don't know why suddenly right down here become like that one, You have something that's pregnant here. No what? Can you see this is curved downwards? I don't know why you're curved upward then like that one, Cannot. It should follow the trajectory. So what I'm looking for is something like this. Can you see? Look, one continuous line, and I did this free-handed. No AI whatsoever that you all say. Oh, you all saw, right? This is not AI. Okay?
That's correct. I only get 1 mark when the question is 2 marks.
Sorry, can you all do me a favor? If I've awarded you a complete take and I only give you 1 mark, can you just add 1 more mark for yourself? Yeah. Yes. If you got it wrong, you do corrections with a green pen and you draw it exactly the way. But for some of you, I drew it for you already. Okay? So, let me explain to you. So basically, it should follow the same trajectory and it should end further. Okay? Because it's got more kinetic energy. Okay, next question. Okay. I know it's a very contentious question. You're going to have to tell me why cannot. I will try my best to explain to you. Fiona's bicycle had a flat tire as shown. Fiona pumped air into the tire, it became fully inflated. As shown in the diagram. State 2 properties of air that cause the tire to become fully inflated. The key question here is fully inflated. And so what are the 2 properties? The first property is that air occupies space. Because if it does not occupy space, it will not fill up anything. The second one, which is a lot of you will contest to it, is air can be compressed. So, okay, let me explain to you. Because in the question, it clearly states fully inflated. And if you have actually inflated a tire before, okay, you need to actually keep pumping air. Even though the tire looks like it's filled up, right? You can still squeeze in some more air one. Why is that possible? It's because air can be compressed. Alright, I know a lot of you, the second one you put, air does not have a definite shape. Okay? But that is actually not the main thing. Not the main thing. The main thing is that, okay, it can be compressed, so you can squeeze more. Though that actually helps, but the 2 main thing is this. So this is actually real life application. Now, another thing is, the most complete answer should be, air does not have a definite volume which allows it to be compressed. Why? Because air does not have a definite volume, tells me that that is the property, that then the result would be it can be compressed. Okay, but they're actually looking for these 2. Any questions? No? Next. Okay, Sammy made a toy with 2 light bulbs that are controlled by a switch. People, is only 1 switch. After 1 bulb blew, the other did not light up. When the switch was closed, state how the 2 bulbs were connected in the circuit. So, you need to say that the 2 bulbs were connected in series. Okay? So because if it's in series, when one fuses, there is an open circuit. Semi change to another circuit. So you see another circuit. So basically when one change to another one must be parallel lah. They say another ma. So that, okay, and the switch, okay, new bulbs L and R, and the switch so that the bulbs will work as described. When one bulb blows, the other will still lit. So this double confirmed to me that they need to be parallel. If one bulb blows, both bulbs will light up only when the switch is closed. Now, this tells me that the switch needs to be in the main line, usually next to the batteries. In the wire next to the batteries. Okay, this is the hint. Because, and then after that, you can roughly draw something to help you. So you know, right? Actually, it's going to look something like this. This is your battery, okay? And then there is like a switch somewhere here. Something like that lah. Okay? This is how it looks. There's no battery, is it? Oh, then the battery is here. Okay, so you can use this to actually help you. How do I know that this is series? Remember positive to negative, so this is one complete circuit. Agreed? And then when this is another complete circuit. Agreed? And then look, only when this is closed, all will be light up. There's no way. So straight away, I will look at this and I use this to help me to draw this. Okay? So what do? I can always draw one circuit first. So I draw the first circuit. Okay? I use pencil. I could be wrong, but I know that whatever the case is, there must be a switch. Okay, and then after that, Mr. Chong says, okay, I draw one circuit first. So no need to say lah, okay? The one circuit, I must make sure that one is connected to the side and one is connected to the bottom.
Oh my god, this line is so straight.
Okay, something like this. China. Okay, I'm trying my best. I know what you're gonna say. You're making a lot of noise.
AI.
Okay. Now, then after that, the next thing is, this one is actually this one over here. Agree? Agree or disagree? Agree or disagree? Next, we are going to have to draw this part here. I have two wires that I need to connect. But I don't know where or how to connect. So there is a few ways to connect it. Okay? So remember, look at this thing. This wire here, this wire is actually this wire. So I'm supposed to have this additional part here. Ta-da! Right? Ta-da! So what I've drawn is I've drawn this wire. Agreed? So then I need to draw this part ma. Correct? So then after that I draw from the bottom. Yeah, you're going to say open circuit again, right? Annoying people. Come on. Yes. Okay. Ta-da! So then after that we check. Flow, yay, light bulb light up. Correct? Any issue? No. One more round. Any issue? No. So if this one bursts, I just go one round. Yay. No. If this one bursts, I can still continue. Yay. So that is how I check. Oh my goodness, I'm so genius. Wow. So basically, you use this to help yourself. Okay? Yeah lah, draw lah. So I was very nice. As long as you both of the bulbs, one side out from the side and from the bottom, I give you half a mark. Yeah, I'm very nice. Oh, sorry. Can you give yourself another 2 more marks? Wait. Later first. Okay, later first. Can or not? Okay, now. Okay. Can we finish up question 40 very quickly? Shh. I know it's recess. Very quickly. Tom prepared a turkey at room temperature and heated the oven to 160. He placed the turkey in the oven to cook. The turkey was cooked for 2 hours. He then insert the thermometer, okay, into the turkey to check. So when you look at this, ask you to read, state the thermometer. Hello, some of you really cannot read 70. So what is this? 74 lor? 75 was here. So it's one less. So answer is 74 degrees Celsius. If your degree Celsius is missing, minus half a mark. State why the temperature is not 160 even 2 hours. It's very simple. The turkey is a poor conductor of heat. That's it. And if they ask you to explain, what do you say? Hence, heat is gained from the hotter oven at a slower rate. But they say just state. So this would do.